Chapter 6, Periodic Table 6.2, Periodicity Part 2. At the end of this lesson, you should be able to define electronegativity and explain the variation in electronegativity across period 2 and 3, as well as down to group 1, 2, 13 to 18. This is the periodic table of elements. Generally, the electronegativity increase across the period and decrease down the group. Factors that affect the electronegativity is atomic size. Previously, we know that atomic size depends on the effective nuclear charge and shielding effect of the elements. Smaller atomic size equals to higher electronegativity. It means that if the atom is having a small atomic radius, then the electronegativity is high. Across the period, the atomic radius decreases. This is due to the proton number increases from left to the right of the periodic table. When the proton number increase, effective nuclear charge will also increase. What happens to the attraction of the nucleus towards the valence electron? It becomes stronger. This is why the size of atom decrease. Since across the period the size of atom decrease, the ability to attract the bonding electron increase. Therefore, the electronegativity increase. So we can see that from left to the right of the periodic table of elements, the size decrease but the electronegativity increases down the group. As we know previously, down the group, the size of atomic radius increases. This is due to the number of shells filled with electron which increase down the group. What happens to the shielding effect? It increases. When the shielding effect increases, the attraction of nucleus towards the valence electrons becomes weaker. Therefore, the size of atom increase or become larger. Since the size of atom down the group becomes larger, the ability to attract the bonding electron decrease. Therefore, the electronegativity decrease down the group. Quote of the day: negativity is the enemy of creativity. David Lynch. Before we end this part of the video, let's try some exercise. You may pause the video and try it yourself before checking out the answer. This is the answer for exercise 1. Thank you for listening.